Welcome, or hopefully welcome back to the Reliability Matters podcast. Today, we're diving into one of the most transformative innovations of our time, electric vehicles and the vast infrastructure needed to support their growth. Joining me is Brian O'Leary, Global Head of E-Mobility and Infrastructure at Indium Corporation, a leading expert with deep insights into the electronic assembly industry and its crucial role in the EV evolution. As electric vehicles continue to redefine the future of transportation, the reliability and scalability of the infrastructure that powers them, particularly public EV charging stations, have become pivotal challenges. The electronic assembly industry is at the heart of these systems, from the semiconductors enabling fast charging to the sensors ensuring safe and efficient operation. However, with nearly 26% of public EV charging stations estimated to be non-functional at any given time, reliability remains a significant hurdle. This episode will explore the major reliability issues plaguing public EV charging stations, including power instability, component failures, and environmental challenges. We'll also explore how innovations in electronics design and assembly can address these challenges, from improving thermal management to leveraging advanced materials like those developed by soldering materials manufacturers. And we'll discuss the exciting opportunities for the electronics industry to lead the charge in building a more resilient, reliable, and efficient EV infrastructure. Brian O'Leary brings a wealth of knowledge on how advanced materials, smart assembly techniques, and innovative designs can solve these pressing issues and accelerate the adoption of electric vehicles. Together, we'll review the technical challenges, explore solutions, and look ahead to the bright future of electric mobility. Stay tuned as we unpack the intersection of electronics and electric vehicles, the challenges and the opportunities that lie ahead. And we'll do all that when I return in just a moment. Stick around.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Brian O'Leary, back for an encore performance.
Thanks for the intro. That was great.
You can just use it on everything, right?
That's right.
Yeah. Well, again, thanks for agreeing to do the show. One of my favorite subjects, if my audience has been on this podcast for more than 4 or 5 episodes, you'll know I always like to talk about cars, and in particular, I find EVs fascinating. I do not own one. I'm sure I will at some point, probably sooner than later, I would estimate. But I do find the whole subject of electric mobility fascinating. Not just the fact that cars can run on batteries, but the tech that goes along with it, I find fascinating. And one thing I should probably preface is, in the intro, watching it again, in the intro, I realized that I think I may be stating that all the issues we have with electronics in cars are strictly related to EVs. And of course they're not. The average internal combustion engine car has an awful lot of tech. It probably shares a lot of the tech. I don't know what percentage, but a high percentage of the tech. The infotainment systems, the ADAS, all the various safety systems and comfort systems and all that stuff are exactly the same. It's just the propulsion systems that are quite different. So a lot of what we're going to talk about today is not strictly exclusive to EVs. Electronics play a very wide role in all sorts of forms of transportation, whether it's internal combustion engines or electric powered. Fortunately, internal combustion engines don't rely on the current EV charging network. And I'm not talking about Tesla in this case. I'm talking about everyone else. Because if they did, I think the problem may have been fixed by now because of the ratio of internal combustion engine owners and EV owners. I think the power of more people would be better. So now that I've done my little rant and disclaimer, What's going on in the EV world, Brian? I see your blogs and your videos, and you're having cocktails with EVPs of Ford and all that. I mean, you're connected, man.
Yeah. Yeah. Well, let me first start by saying I did get my first EV.
You
And
did.
that probably surprises a lot of people. Like, wait a minute, you've been talking about this for years, but you don't own one. So I got summarily taken to issue on that by a bunch of EV journalists when they all asked me, "Well, which one do you drive?" And I was like, "What?" So I took the plunge. I got one. I got a heck of a deal. And
What'd you
I got to
get?
tell you. Okay, now I'm gonna get in trouble.
Now you're going to get in trouble because no, you're going to make someone really happy and about 8 other players really upset.
Well, let me preface it by the deal that I got. You couldn't beat
There you go. Okay.
It was amazing, especially living here in Colorado. The incentive was unbelievable. I'm leasing a Nissan Aria, which is their high-end model.
Yeah.
And a friend of mine, so this is a good story. A friend of mine heard about this, like, oh, I got to get one of those too. Well, the use cases couldn't be more different. I've got a garage, vehicle comes home. I don't even drive it. It's my wife. It's her ride to work. And it's usually at 90,
I like that.
90
Honey, I got a car. It's yours.
Yeah. It's usually at 95% state of charge continuously because of the range. But my friend I was talking about lives on the other side of the mountain of Colorado in Grand Junction. They live up on a hill. They don't have a garage, and they want to tow their trailer to go camping. And I'm like, absolutely not. Do not get an EV. You're not
Right.
going to be happy.
Right.
Maybe get a plug-in hybrid electric vehicle or something similar. But to finish the story, they showed up with their new Toyota. I'm trying to remember which model, but their lease is twice as much. Their down payment was twice as much, and they got a gas engine. And I'm thinking, I got a really good deal. So
Yeah.
there are deals to be had if you're interested in taking the full plunge. But
Well, I know the federal government is still offering rebates. I believe they're still offering rebates, like $7,000 or something like that. And then various states offer their stake in it as well.
And if you lease, you get kind of a backdoor loophole where as the leaser does get the federal funding, even if the vehicle is not assembled and in great part manufactured in the United States, which is not true if you buy it. So they get the savings, the leaser, and they pass it on in just a smoking deal with your lease payment. So that's how
Wow.
I tell.
We'll miss those days once they're gone because at some point they'll be gone. We both work in the electronics industry, and one of the types of customers we both work with are automotive manufacturers and the electronics associated with it, all the peripheral companies that surround Detroit and other car-producing cities that supply electronics to the manufacturers. And at least in Europe right now, I'm hearing of travel bans and things like that, meaning they're really tightening the belt right now. Anyone in the automotive world is hurting at the moment. What's behind that? Are you aware of that situation? And I know it's cyclical. It's spend money today and save money tomorrow. But what's going on in the automotive world, whether it's related to EVs or not?
So let's set the facts straight because the press likes to, no, they never say anything that's dramatic or
Exactly.
But, this EV thing is a fad and it couldn't be further from the truth. First of all, the automotive industry in general, worldwide, has not been doing well for many years. But the bright spot is the EV side, and it continues to grow, double-digit growth, even here in the United States. What's happening is the reality of a lot of competition, for one. So all these boards of each of the individual OEMs will say, hey, we're going to sell 2 million vehicles. Well, 10 others are saying the same thing, and the market can't possibly buy what's being forecasted. So I think that's part of the headwinds that some of the manufacturers are faced with. There's the other reality of the legacy versus kind of the tech startups, if you want to call them, like the Teslas, the Rivians, and so forth. they're having a tough time. This is a tough pivot. Some of the OEMs have strategically kind of bifurcated their business. Ford's done that with Big Blue and 40, where they've separated out the two units and how they invest their R&D money. They can kind of manage their business a little bit better, but still they're taking massive losses. And this was not unexpected. This was expected. This is a big retooling. GM's going through the same thing. Stellantis, they're a little bit wobbly right now, but it's definitely a struggle. That being said, you can't discount what's happening in China, and it really has a lot of people on their back foot. There was a conference fairly recently in Europe where they were talking about Chinese automotive, and the Europeans as well as the Americans in attendance. There was a palpable fear in the room. And part of that is due to the fact that not only are these vehicles low cost, relatively speaking, but the tech is awesome. It's not as if, well, they're just cheap Chinese. Come on. We moved way beyond this. This is affordable, high-tech, high-value vehicles hitting the marketplace, and it really has a lot of OEMs. Like, for example, this conference was hosted in Germany. I mean, you can imagine for the Germans, you got to move faster. That's not in their DNA.
Right.
So it's a real
slow and methodical. It is that way. So what? Oh, so many questions now just hit my head. I don't even know if we're going to get into any of these questions here. Why is it? And this is a deeper question. It's probably more philosophical than literal. But why is it the Chinese can decide, okay, we're going to infiltrate the EV world and do so successfully, so quickly, and so inexpensively? I know their labor costs are lower, okay, but Eastern Europe has low labor costs. Parts of North America have, and South America obviously have low labor costs. So taking just the labor argument out of it, how is it that they can build an EV that is so good, so feature-rich, so inexpensively, and penetrate a market so quickly?
Right. So there's a lot to unpack there. I think let's start kind of at a 40,000-foot view. So when you talk about an EV's architecture, EE architecture, it just from a pure design and manufacturing standpoint, it's a lot simpler than an internal combustion engine. You have tens of parts versus thousands of parts.
Yeah, it's an amazing comparison. Yeah, absolutely amazing.
That in itself, right? You got Lego blocks versus, a 1,000-piece puzzle. It's very, very different. So that's number one. Number two, you've got a lot of electronics tech companies, because the barriers of entry are much lower with EVs. Look, Tesla got into automotive. Everybody thought a lot of people thought they would fail. I mean, hedge fund companies that bet against Tesla lost billions thinking it would fail.
I think there was a time Elon thought it would fail too. I mean, it was a toss-up.
The reality is it's not, I wouldn't say easy, but relative to the old combustion engine, it's a lot easier to enter the market. So that's number two. Number three, and I think this is, there's 4 points. Third point is the Chinese government is a command and control government, put a lot of money 10 years ago into this, and now we're seeing the fruits of sowing those seeds 10 years ago. The rest of the market's trying to catch up, and it's tough. You just can't turn it on. So massive investments that got a head start. But I think fourth, and most interestingly, many of the guests, or I should say many of the listeners to this might have heard of software-defined vehicles. This is the new architecture. We're right on the cusp of this happening. And to kind of define it in itself is a challenge. There's still some consensus on what it means, but I'll give you my kind of simplified definition of a software-defined vehicle. It's basically a bifurcation of the hardware from the software, number one. Both are able to develop independently of one another. And after the product is built, it continues to improve. So think of it like your iPhone.
Over-the-air downloads, yeah.
your over-the-air updates is what they call it, OTA.
Yes.
So you're able to add additional features and capabilities in the future after the vehicle has actually left the manufacturing facility. In the context of China, what they have been doing very aggressively is they just get it out there, get the product out there onto the streets, and then tweak, and then tweak it some more.
They didn't invent that. I think that process was probably invented by Microsoft. They were notorious, and even to a certain degree, Apple. They're notorious for launching the product, fix it later.
And then, and of course, you and I both know when you go over the China regulation and how things are done, things are much easier to get done in China, like in the West. So they have that sort of built-in advantage as well to innovate quickly.
Yeah. So I'm just going to kind of throw these questions out because I love the way this conversation is going. What part of the electronics industry has, or what advancements in the electronics industry have contributed most to the growth and the sophistication and the capabilities of EVs? Is there any particular advancement where all of a sudden the manufacturers are like, finally, now we can introduce the car,
I think to answer that question, a couple different areas. In the context of automotive in general, so it's not just EV, this is agnostic to the whole automotive industry, is advancements in like system on chip packaging and what we see in other industries has been adopted by automotive. So it is a computer on the wheels in the sense of the power that's in these vehicles. Everything that you see with autonomy, as an example, some people are familiar with AI on the edge. It basically means you have to have a lot of this stuff on board because you can't have everything communicating with the cloud if it's a car, right? So that means these vehicles are packed with tech that we've never seen anything like it just even a few years ago. So the enabling technology here is what we kind of pull from other industries. It's just that now they're finding it into vehicles, and partly because of cost. The costs have come down. That's just on the sort of the intelligence side. The other part of it, which is specific to the drivetrain of an electric vehicle, is silicon carbide technology. And silicon carbide, it comes into play when you've got high voltages and basically it's a switch, right? Power electronics is a high voltage switch. So silicon carbide lends itself really well to higher temperatures and more thermal cycles. Because the reality with an electric vehicle, if you think about it, mine's in my garage right now plugged in. It's doing stuff. It's not like your combustion engine in your driveway that's just completely off and cold. This thing is working, and it's pretty much working around the clock. So that means now that I was talking about the power electronics, that's a little bit different, but that's just in general a load that you're putting on all the electronics in part in the vehicle for the over-the-air updates is one of them. But getting back to the electrified powertrain, if you've got an F-150 Lightning and you're towing something and you want to gun it to show it off to your friends, the amount of stress that goes on those switches is just unbelievable. So the tech is the enabler here, the silicon carbide that I was speaking of.
Yeah. I think there's been quite a bit of tech. I'm not sure if it's software tech or electronic tech or a combination of both, probably both, in battery management technology as well. A typical array of battery cells is capable of producing so much energy. And that's one measurement of range. That's one input to the range capability of any vehicle. I think the other side of that is battery management. It's the control of the power, the distribution of the power, to make use of that finite amount of energy. How has the EV industry benefited from extended range without just getting bigger batteries? Have electronics contributed to that extra range given a finite capacity on a battery?
There are certainly, and part of that is with the over-the-air updates, software-related tweaks to
Right.
help with what's called the charging curve. So that's, when you plug in your vehicle, how quickly can I get from, say 20% up to like 80%? Part and parcel is the software. So yes, the other part of it is the capabilities of the BMS or battery management system. How really the hardware, how advanced it is at the time that it was built. Some have done a very good job. There's certain models. People ask me, what should I buy? You want the best gosh darn get in, get out vehicle to charge? Is probably a Hyundai. Ioniq 5, I think, has one of the best charging curves. Other awesome cars out there are terrible at charging. And a lot of it, it's not just the chemistry, it's part of it, but also the software as well as the design of the BMS. So they all kind of have to work together.
I saw I like watching car reviews, and there's a few channels that I watch, agnostic car reviews. And one of the channels was focusing on an EV that was made in China, not available in the U.S., available in Europe though. And one of the new releases for this manufacturer was the ability to go. I think the range was probably 250 or 300 miles, and it promised the fastest charging on the planet. It was like 10% to 85% in 20 minutes, which is a slow day at the pump. That's a slow experience at the gas pump. But what in your opinion would be the difference between one manufacturer being able to offer decent range and super fast charging? Maybe the answer is in the charging stations that they have versus the ones that we have. But what are the differences, and why do you think one manufacturer or maybe one country can offer something so radically different than what we have here?
That's another interesting one to unpack. I'm going to kind of attack this with a sort of a different question answer.
There you go.
What do you need? And that's a very different way of thinking. EVs are more akin to the way you charge your iPhone than the way you gas your car. You're basically sipping all day. So if you start from that premise, then it leads to the next question. Well, why do you need rapid charging? So I've owned this EV a month and a half. I have yet to use a rapid charger. I just don't need it.
But if you were to come visit me, if you're going to do a road trip, you and your wife, and you're going to come visit me in California, right, that's probably not the car you're going to take.
Exactly. But let's say that I did. So I have about 300-mile range, and I know how far you are. So there's going to be a few stops, and you would time those stops like, hey, let's charge it when we're getting lunch. That's kind of the use case perspective. Now, to more directly answer your question, what's the difference between technologies and how does it enable this fast charging? You're right. There's a lot that has to go right. There's the chemistry in the battery and the type of pack design. We talked about the VMS. There's the software. And then there's the actual charging station itself. And it's not uncommon here in the United States right now, and there's a lot of talk about this. You've got this brand new minted, let's say about $500,000 DC fast charger. That's all in. That's the cost of the hardware, installation, dredging, all that kind of stuff, or trenching, I should say. $500,000, saunter up to it, plug it into your vehicle, and you're getting like 50 kW when it's supposed to be 3 times that. Well, what's going on? Well, the provider is throttling you down. Remember the old conversation with high-speed internet? It's like,
sure,
wait, I paid for this, but I'm not getting it.
Right.
Well, for a variety of reasons. They could be purposely throttling, or that station has somebody else plugged into it, and you're all coming off of the same kind of juice, right? So you divide it in half. So you're kind of sharing the same. So it's not straightforward. And, one of the things that's really difficult for folks to figure out is, well, how fast is it really? How quickly can I do it? It depends. And it's even for one vehicle, it depends. It depends on what you're plugged into, what temperature it is. There's so many things, so many factors.
So you living in Colorado, will you experience in the wintertime less range or more range? What's better or worse for a battery, cold or hot?
Cold.
Cold.
Well, actually, that's funny you say that. I think technically cold is worse than super hot, like if you're in Phoenix. Batteries surprisingly like about the same temperature we do as humans, around that mid 70s. When they get below freezing, they don't do great. You probably, if you ever hiked with your phone in super cold temperatures, you notice, why is it not working all of a sudden? Same reason, because lithium ions, the ions, don't move around so well in the cold. And same goes for heat. They're not as efficient. But a lot of manufacturers have ways to get around that. So one of them is a lot of modern EVs. It's funny I say modern, they haven't been around that long.
Right.
But a lot of them will have a preconditioning to the battery pack. So if it's cold out, a little energy will go into making sure it's at that nice, warm, human-like temperature before you take off. But to answer your question, if you've got your EV parked outside all night and it's 20 below, it's going to be a tough morning. You might lost a lot of your range.
Right. Yep. Well, it's like diesels. Diesel. They used to put glow plugs in them. I think the technology's improved since then. But you used to have to, go, with your coffee in hand, pajamas still on, go turn on the glow plug, and then go back in, finish getting ready. And by the time you came out, your truck would start, or your diesel car would start. Speaking of battery tech, when I fly, you and I both fly a lot, right? We're kind of road warriors. And I don't know why they call it road warriors, because that's kind of air warrior. But anyway, we're warriors when it comes to travel. And one of the questions that I always answer no to, because I'm asked every time I check in, when I check a bag, is, do you have any lithium-ion batteries in your checked bags? And of course I don't, because anything that's running lithium-ion batteries, I want with me, because it's a device, right? It's my entertainment for the flight. So yeah, I don't check those things. However, it causes one to wonder. Airlines don't want lithium-ion batteries in the hold, because there's not much they can do if something catches fire. That's the concern. At least if something catches fire in an overhead storage bin, someone can get a fire extinguisher out. But it makes me think that, okay, airlines don't allow lithium-ion batteries to be in their storage area. And at this very moment, more likely your EV is parked in your garage. And I'm like, okay, we can't take one lithium-ion cell and put it on an airplane in the hold, but we could take 10,000 lithium-ion cells and stick it in a garage. So what's going on with the battery situations with lithium-ion? Is it, we mentioned earlier, the press likes to create drama out of stories. Is it a very small anomaly that just makes a lot of press, like airplane crashes? Airplanes are the safest form of transportation statistically, yet they make all the press when one blip happens. Is it an anomaly, or if we scale it compared to gasoline engines, which obviously have 20 or 30 gallons of highly flammable liquid content stored, somewhere in front of the back bumper, those explode from time to time. Where are we relative to our current level of expectation and safety with internal combustion engines as opposed to battery technology in terms of safety?
So where we are right now today it's kind of the exception, but when it makes the news, it makes pretty big news, because the fires that you do get from lithium, they're very, very difficult to extinguish, and they're dramatic. You have to essentially submerge the whole battery in water, or use some very kind of boutique fire retardants to get it to put it out. But as a percentage of all vehicles, or I say percentage in its group, fires in fully electric vehicles versus fires in combustion engines, combustion still wins as being more troublesome for whatever reasons. But here's the reality. The reality is the BMS that we talked about, the battery management system in an EV, is much more robust, complex, and regulated than the one that's in your little battery pack that you throw in your luggage on a flight, right? So there's a difference there. The other reality, and this is the reality, we're talking about lithium-ion batteries. There's many different flavors. The ones that first hit the scene have manganese, cobalt, some exotics, if you want to call them that. That's what the first Teslas were. We are gravitating away from that technology. Really, the use case for them is going to be just your Porsche Taycan or high performance vehicles. But the mass market is going towards something called lithium iron phosphate. Doesn't contain cobalt, doesn't contain manganese. But what's also very unique about it is it's not as prone to catching on fire. There have been tests, you can hit it with a ballistic, shoot at it, smash it, and do all kinds of terrible things to it, and it won't catch fire. Not to say it can never catch fire, but it's a much more stable chemistry. And this evolution in chemistries just continues. You think, okay, the market's going to go in that direction. Now all the talk is sodium-ion batteries. So forget the lithium. Now we're talking sodium. So to answer your question, with time they are getting, without question, safer. Does that mean they're absolutely 100% safe? Absolutely not.
No. Anything that stores energy, whether it be a liquid or coal or a battery, is going to have some level of safety concern. Are the advancements, you talk about lithium iron and sodium, are those advancements compromising range, or are we getting both an increase in safety and at least stability in range?
There are trade-offs, but some of those trade-offs are being mitigated by other approaches. So I'll give you an example. So lithium-ion batteries, the traditional cobalt containing, has the highest energy density. So think of it this way when you talk about energy density. Gasoline is a really dense material versus an electric battery, right? So the density is by far the most with the older chemistry, but the trade-off is cost, the most costly. We know where cobalt comes from, places we don't like to dig up in the world, not great places. And it's kind of a rare, it's not a rare earth, but it's not like everywhere.
Right.
So it has some limitations. Lithium iron phosphate, iron is everywhere. So that's more readily available. The cost is dramatically less. However, it doesn't have the energy density, so that you do take a hit on range. But what a lot of clever manufacturers are doing is the way that you pack these batteries into the chassis. Usually it's packs of smaller boxes of batteries in bigger frame. Well, what they're doing is they're eliminating a lot of that internal, call it packaging. I'm making this way simpler than it is. But when you do that, that means two things. You've just reduced the weight, which gives you more range. What you also done is you've freed up more room to pack even more batteries in. So it's kind of have a mitigating factor against the loss of the chemistry that had higher density, now going with one with lower. And lastly, it's so much cheaper. It's kind of a trade-off that most people are willing to say, hey, that's fine. Instead of 230 miles, or let's say 300 miles, now I get 230. For most people, it's like, do I really drive 230 miles at a shot anyway? No, you don't.
Yeah. Let's talk about kind of the fly in the ointment when it comes to EVs. In terms of, from my, adoption standpoint, one of the well-publicized issues with EVs isn't with the EV, it's with the infrastructure for EVs, the public charging stations. According to a 2023 study, so as we're recording this, it's late November of 2024. So just last year, there was a study conducted by University of California, Berkeley, and they concluded after studying 600 plus charging stations in the San Francisco area, so relatively small study, that 27.5% of those chargers were not functional for some reason. In 2024, this year, The Verge published a study which was conducted by an association called Charger Help that reviewed 20,000 public EV charging stations. This is one of the larger studies, if not the largest study on this subject. and they concluded that 26% of them were broken at any given time. So, we're not really moving in the right direction. We're not moving far in the right direction. And that was a pretty big study. Now, there's a lot of reasons for this particular issue. But just to put it in perspective, it doesn't take a lot of convincing to put this in perspective. If 26% of all commercial flights today broke down, if the airlines had to cancel 26% of their flights, do you know how many people would be affected? 3.9 million people. 3.9 million people would miss their flights. Not to mention any knock-on effects, probably tens of millions when you figure that flights are connecting to flights that were also going to get more people, but 3.9 million people would be affected. That's huge. 26% of public chargers not working at any given time is a real issue. So I have all these things that I'm going to ask you to unpack. One of them is what's going on. The other is why is Tesla an outlier in that? When they say public charging stations, they're not referring to Tesla. Tesla is a kind of a private charging network, at least at the moment, although that might be changing.
That's changed, but anyway.
Yeah, it has changed, yeah. So let's start with what's going on from the electronic standpoint. So a little bit of research tells me that there's a number of reasons that EV charging stations fail. The top 6, according to multiple reports, are inadequate thermal management. Something overheats. That would probably be electronics. Power supply instability. So the utility not providing constant power. Communication failures, chemical migration, foreign object debris, so environmental factors. Component aging and wear exacerbated by high power loads, that type of stuff. And then I'm sure in there are stupid people tricks, vandalism, people drive into them, they're in a rough and tumble, environment. So based on your experience, what's the comment on the 26% of EVs failing or EV charging stations failing? Do you believe that number is accurate? And what, in your opinion, are the major reasons within the control of the electronics industry that can mitigate that? And then finally, and I'll keep track of the questions, and finally, why is it one company can do it very well and the rest of the world seems to not be able to? So we know it's possible.
Right. There's a lot of ways to answer this. And I'm going to first off, for the audience, I've been focused on this now for like the last 3 years, trying to get to the actual answers as to why. And it's been a journey, and the data and information out there is a bit spotty. So what you just sort of gave as your findings is actually good for you, because most people can't even get to that level of information. So, and there's reasons for that. But I'm just going to do a shout out to IPC. There is a group within IPC that I'm part of, and this is one of our objectives, is to actually get to the why from an electronic standpoint, publish a white paper to hopefully move the industry forward. So where is the industry right now? The industry here in the United States is a bit of a laggard versus other markets like Europe. They've learned if they're doing better. Certainly China is probably doing the best, but all the markets have somewhat similar issues. Some of it's hardware, some of it's software, some of it is network related, as you mentioned. But let me speak more to the United States, because that's what I've been primarily focused on for the last few years. There is a government effort, and as part of the infrastructure bill, to hold some accountability to what's being put into the field. There is a requirement now of 98% uptime, so certainly you can't have this a quarter of the time you're down, as being part of receiving that funding. The stick part of that, meaning, well, how are you going to enforce that, is yet let's just say we're on our first round. It hasn't been fully vetted. The objective has been more to get product into the ground. That being said, are there standards to which any of the manufacturers are being held to in terms of reliability? No, doesn't exist. Does not exist. What standards they're being held to, what's kind of percolating up, and it's been a lot of work from NREL and a few other labs, is more, how do you deal with the error codes? When you get an error code, let's get some consistency from platform to platform that a field tech knows how to respond to that and figure out how to fix it. But there is no underlying effort as an industry. Let's build product that's going to, we're going to put it by a seaside resort with salt air. Maybe we should protect that product a little bit more than if it was in my garage. Meaning,
conformal coat the boards and...
Wouldn't that be a good idea? There is nothing that says you need to conformal coat a product. Matter of fact, Matt mentioned Charge Health. I was talking to the CEO not too long ago, and she said, there is product put in the field where literally the irrigation sprinkler system on site is hitting the unit every day as it's watering the grass. And you think about it, take a big step back for a second and think about where these systems are deployed. We just kind of, our hunch says, yeah, it's like a gas station. No, it's in the back lot of the local grocery store. It's out in the middle of a parking lot that the snowplow in Wisconsin just covered with that mountain of snow that they used because they didn't know what it was. That seaside resort, and there's no rhyme or reason as to how you need to build this, how you need to maintain it. There's a lot to still be sorted. All right, that all being said, what's actually happening and what we're seeing in the field, a lot of anecdotal evidence, not really a whole lot published. But what you do see is all kinds of egress. So whether it be moisture, a lot of these electronics are not protected with anything other than the metal box that's around them. Believe it or not, insects, which is a big problem, especially in Texas. Red ants get into these things.
I was in Amsterdam.
Oh, you were there about the ant thing.
Yes, the ant urine. Someone did a whole study, kind of a whole DOE on ant urine. I don't know how they got a hold of enough supply, but anyway, yeah, that was an interesting failure mechanism.
Talk about kind of folksy discussion here. I've had techs tell me, I don't know what it is, but there's something high frequency maybe on the board. It like really gets hornets and bees angry, and they come in and they actually attack the electronics. I don't know. Okay, but the point is, a lot of this stuff can be mitigated. I'm going to quote Brian Chesla of Dow, which they make potting materials and so forth. He says, I can fix all this for the price of a cup of coffee. And when you think about it, the average hardware cost on these DC fast chargers is north of $100,000. Forget Tesla. They're a different model, different league. But most of the equipment is over $100,000. That's where you have the whole self-contained power electronics, everything in the box. Then you've got to double that, triple that for the actual installation. Why would you not spend $4 or $5 to protect it?
Right.
That is the start where we should start the conversation. And frankly, the industry is just not there yet. What's happening is it's on the OEM to kind of self-police themselves to build quality product. And I gotta tell you, it's happening. I know of several OEMs, I won't mention them on the air, but they are building really quality product. I will mention one because they made it a public announcement, but Alpatronic, which is a European company, they were basically asked by their customer, please come to the United States because I can't rely on what's in the ground right now. Because they have a reputation of building quality product. And I was talking to the senior management recently at their ground cutting in Charlotte, and they came from a power electronics background. That's how they started their business. So they have a mindset already of how you do this. And the power electronics are literally silicon carbide. I mean, it's like top notch. I'm not trying to do a commercial for them, but I'm trying to make the point that the mindset is we're going to put product in the ground that's quality. I can tell you a lot of what's been in the ground failing in the United States, comes from a component was built overseas. It was built maybe from a board house that, it's not like an automotive mindset. The
Right.
difference between
Right.
automotive and something I like to paraphrase a lot of times, you've heard me say it, is they're building a lot of this stuff to an IPC Class 2 standard. Well, that's the same as your microwave oven.
And your copier in the office. Yeah. It's office, basically consumer office stuff,
So what do you expect? Things don't go right. But I will tell you this, and it's a little bit disconcerting, and I'm not saying it not factually correct, but when I go to conferences on this topic, not with a bunch of electronics engineers, but marketing guys and product managers and CEOs, and they love to say, "Oh, it's a communication networking problem," which I'm not saying it's not, but that's such an easy out. Blame it on AT&T or Verizon,
right.
or
And that is one of the factors.
Yeah.
But so much of the, according to the research I've done, the top 6, our industry is in that top 6, and we may not be able to, if we do everything right within our industry, the electronics assembly industry, then I don't think we'll bring the failure rate down to 0. But it probably won't be double digit, right? And other people can figure out, the best way to kill the bees and the ants and things like that, prevent them from egress. How is it? Well, let me back up a little bit. I couldn't find any wide studies on Tesla charging stations. And it could be that they just don't have a reputation for failure like the others, so who's studying it? But they self-report. Now, take that with a grain of salt because they're self-reporting. But according to their report, the failure rate on day-to-day failure rate on their charging stations is 0.003%.
So I'll make a comment on that.
Yeah.
First off, I can tell personal experience, they do build a quality product. I mean, they've been at it for a while. They have a larger install base than anybody else. From a cost structure, very hard to compete against. Their deployment cost is a fraction of like anybody else. I mean, there's not even a close second. A lot of that has to do with pre-planning. When they put something in the ground, people go, "I can't believe how fast it happened." Well, they've been working on it the last 2 years or year or whatever to get it in place. But the other part of the reality is, and I don't think this is well publicized, and I hope I'm not mischaracterizing it, if you've got 10, 20 superchargers on a lot, and if you're the vehicle pulling in and the first one doesn't work, then you go to the second one and it does, that's considered 100% uptime. You see? Because you were able to complete a charging session. So part of it is how do you define it? So if there's 20 chargers and 20 cars show up, now that's a different story. But most supercharger stations, if you look at them, they're not full for the most part. I mean, there's exceptions. So if there's a hardware failure, it doesn't get counted. If you're
That's interesting. So their version of counting, if that's accurate, their version of counting uptime is whether a customer is denied the opportunity to charge rather than the machine denying an opportunity.
So the standards that are now being used here in North America to come up with that 98% uptime, a lot of that is, are you able to finish a charging session? So having the unit on and powered on, and I plug in my vehicle and it doesn't do anything, that's considered it doesn't work. That's a mark against you. You see what I'm saying?
Yeah.
It's not that. And the other reality, and I should have mentioned this from the top, and folks are getting better at this, but the reality of a lot of the equipment that's out there, when it doesn't work, the operator doesn't even know. Because up to this point, and things are changing, there's not enough sensors packed into that device to be able to send to the operator, who's typically remote, mind you, gas stations, attendant, pump, hardwired, right? EV stations, remote, and working off the network. And whoever is managing it is probably far, far away. So they've got to wait to get some sort of input from the customer. Customer has to call the 800 line and say, this thing doesn't work. Oh,
Well,
now they're
chances are
getting better.
Yeah, chances are they're just going to go to the next charger and forget the 800 number, right? So
Yeah, well, and that's that study, by the way, that you cited at the very beginning, the Berkeley study. I've actually read that in detail a few times. But the other interesting part of the study was after they went to those 600 stations and found 24% not working, they actually called every service number. The average wait time, I think, was 8 to 10 minutes. Now, if I was a consumer, I'm out of here. I mean, you and I've talked about this. I go to a gas station, and if I swipe my credit card and says, go see the attendant, I grumble, go to the next gas station.
Exactly. Yes, exactly. Yeah, I'm the same way. Yeah, I'm not doing that.
They actually followed through with the phone calls, got somebody on the other line, and then they returned, I think it was 10 days later, a sampling, and I think 0 were fixed. So that's the other part. And that's a human problem. That's a system. That's not a hardware issue.
Right.
That's
a human
how you're
problem.
managing the asset.
Yeah. So why is it that, how is it and why is it that Tesla largely gets it right and all the other companies that make similar, public charging stations don't? Is it some secret knowledge base? Is it motivation? And I'll throw out maybe a suggestion and tell me if you think it's accurate. Tesla owns the charging network. They want to sell cars. They assume that all of their customers are going to go to a Tesla-owned charging station. So if it doesn't work, Tesla looks really bad. If I'm General Motors or Stellantis or Nissan, and their reputation's not affected when the 76 gas station pump isn't working, right? People don't go, damn Nissan, the pump's not working. It's a whole separate mindset. Is that really part of the motivation, that it's like not their problem? Because it is their problem in a larger sense, but it's not their problem in terms of, responsibility. Is any of that accurate?
No, I think it makes a lot of sense. But let's also look at the history of Tesla. Charging network was a means to an end, like you said.
Right.
You got to have chargers to, fuel or electrify our vehicles. Of course, that's changed rather recently. The NACS, which is the North America charging standard, which is the Tesla plug. That's what that is, right? Most OEMs now that are either selling currently, most OEMs that sell currently in the United States have announced that they are going to have a NACS socket in their vehicle, which only a Tesla charger, but a lot of the third-party charging equipment is also building their chargers to have the NACS plug as an alternative to CSS, which is the kind of the standard for everybody else. And I got to tell you, true story. So when we were looking at vehicles to buy an EV, we went to Nissan. We looked at the Leaf. And we said, no way, because it uses something called CHAdeMO, which is unique only to Nissan, and nobody wants to build those anymore. It has the CSS, which you can pretty much access anywhere you want to go. Tesla got it right, because Tesla was like, hey, we have our own proprietary network. We've built it out. You're never going to have a problem with charging if you need to go public, and nobody else can use it. But now they've changed that. So now the network has been opened, but it's no secret that Elon has very publicly stated he's not so interested in building cars anymore. He's going robo.
He doesn't want this anymore, right? He doesn't want steering wheels.
So,
yeah, he's bored with that.
And the other reality, a lot of people don't know this, but Tesla made a lot of their money off of government funding. So by the way they were able to, there's the carbon offsets and all that, and how they were able to do public charging, they get a lot of income from the U.S. government in building out what they've done. They're no dummies, and the other guys haven't been really able to avail themselves of what they've been able to do.
You're in the solder materials world, and what are the differences? If I'm building electronic flea collars, for dogs. I'm going to say, hey, Brian, what kind of solder paste do you recommend for my little, double-sided single layer
Well, we wouldn't
board?
even be having that conversation.
Right. I wouldn't make it up to Brian. I would be some person lower down on the totem pole.
That's what we call class one. You can go with the toys and everything else.
Yeah. I'm building cheap class 1 stuff where if it fails, the only repercussion is an itchy dog. What's the difference between the array of product that would be suitable for that application versus, hey, Brian, I'm starting a new EV venture and we need to build ADAS systems and blah, blah, blah. How small does my world get in terms of suitable materials, and what would drive one material over another?
It's pretty quick. Your world's going to get smaller. I would say up to recently, you could still work in a kind of a SAC world as an alloy.
SAC 305 or
like a SAC 305. And it was mainly because a lot of these builds still had sort of the same thermal requirements, temperature ranges and all that kind of stuff to function properly. That has now largely been shifting towards higher duty cycles or emission profiles. Like I said, the EV is on all the time. So with that type of environment, these materials have to stand up to a lot more abuse. You can get kind of, fatigue cracks and, not so nice things happen with a SAC 305 alloy. So the trend right now is more and more of high rel or high reliability alloys. Indium Corporation has its own flavor. We call it Durafuse. There's been other products on the market that have been out there as well. So that's that's sort of the arms race right now in my industry, is who's got the best, because you're not just looking at the alloy itself, but you're also looking at some of the chemistry and how it impacts voiding. And voiding is a big one in the thermal space as well as electrical. So that's kind of what's happening in the solder paste world. Automotive in general is kind of moving in that direction. Take a hot spot is like ADAS. So everything that has to do with the vehicle's ability to see its environment and react. Boy, you can't have that fail, especially when there's some sort of autonomous feature to it. So these materials have got to be bulletproof, and that's what keeps a lot of these engineers up at night.
Speaking of autonomous, are we going to see not just an autonomous vehicle? There are autonomous vehicles today. They're driving around cities like San Francisco and occasionally hitting people, but overall they're pretty reliable. Are we going to see a world in our lifetime that is completely autonomous?
Already happening. This was our last conversation now.
But no, completely autonomous, not just, hey, there goes a driverless vehicle, but a world where we don't drive vehicles anymore, except maybe for fun. For nostalgic purposes, we'll go to a racetrack and we'll be able to actually turn a steering wheel. But do you see that happening in our lifetime? Elon's vision of a world full of autonomous vehicles?
So you asked me this question last time, and I would say it was probably been about 18 months ago. And my answer would have been, I don't know. It was kind of on.
It sounds like you're more optimistic now.
But what's happened in the last 18 months, I'm thinking, yes. In our life. Yeah. It may still be, only certain areas. I don't see these vehicles on country roads, but let's go to my experience. So I got this Nissan Ariya. It has mapped out certain highways in my area, and I'm not supposed to, but I can take my hands off the steering wheel. It'll start yelling at me. Lights go off and it vibrates, but it literally could drive itself in certain parameters. It knows where the lines are on the highway. It sees the cars around me. It knows when it slows down automatically. I mean, some of these technologies are not new, but it does it in a way that, I could see we're getting there. Definitely getting there.
I know Tesla has a whole different vision. Elon Musk has a whole different vision in terms of self-driving. He likes it to be all camera-based as opposed to LiDAR-based and things like that. General Motors has their Super Cruise, which basically pre-maps certain highways, and it's memorized the highway, and then it looks using LiDAR and or cameras at the current situation that day, but it has to first map a highway for you to be able to turn on that feature, where Tesla and some others will basically just wing it. Very sophisticated way of winging it. It's going to be interesting to see. Personally, I think that autonomous vehicles will be at its safest level when we get rid of human drivers. It's the combination of predictable versus unpredictable behavior. And in a world of where everything is autonomous, it's not just every autonomous vehicle being able to make decisions on the fly. It's knowing the intention of every other vehicle around it, because there's a flight plan, so to speak. And I do see the day when everything is autonomous that it'll be way more efficient because traffic signals will be coordinated to maximize efficiency and flow. Instead of saying, hey, I'm just going to go in, I'm going to go to the store and buy milk, I'll program, I'm going to go to the store and buy milk. I want to be there at 4:02. And it'll tell you, like an airline schedule, okay, be in your car ready to go at this time. And you might have a ground hold like they do in the aviation world. You have a ground hold so you don't end up circling, burning up fuel, for 40 minutes before you land. They'll just keep you on the ground where it's more efficient. But in that case, what the FAA does in the aviation world is says, look, if you're willing to wait on the ground for 40 minutes, we'll get you straight in. So you don't have to do the whole hold thing. And airlines realize they're spending money in the air. They're with fuel, they're not burning that same amount of fuel on the ground except for the APU. So it's much more efficient. I see a world where we just program where we want to go and it tells us what time to leave. And we can say leave now, and we have a lower priority with traffic lights, or if we let the system recommend it, we may wait longer to go, but we have a shorter drive experience. I can totally see that happening once the world is fully autonomous, because you throw one or two random human drivers in there with its unpredictability, that's kind of what computers
my gut
don't know.
And I know we're kind of wrapping this up, so I'll keep it a bit short, but my gut is the Chinese are going to really capitalize on this sooner than anybody else. And I say that only because they have built an infrastructure to support, it's not just the vehicle, but it's the Internet of Things embedded in the highway system. It's the satellite telemetry, their own proprietary GPS working in concert. It's like that triangulation between these different techs. So in other words, you pick up that vehicle from China and throw it in North America, it's going to lose capability, at least for now. But they are way ahead. You go over there, I'll make this real quick. It's with one of my colleagues. You could see on the infotainment system screen, you could see somebody opening their door virtually in front of a truck where our line of vision was blocked. But you were going to move into that lane. And I said how is that possible? How does it see that? Because the camera can't see that. He says, it's because the Internet of Things, telemetry with satellite technology, and what's on board in the vehicle. And then he made the other statement. He said, do you know that North American GPS is about 3 meters of accuracy? He says in China, it's 1. So it's like, wow. So they're just further along for a variety of reasons, good or bad. I don't know if I want that degree of surveillance in this market. So I have these little, features on my car, but in China, they're perfectly happy with that.
Well, it's kind of the norm. Yeah. With the bad comes the good and vice versa. So as we finish up here, what are some of the biggest opportunities in your mind for electronic manufacturers, for CMs or OEMs within this constantly evolving EV world? Where do we stand to benefit most?
Wow. Electronics manufacturing in general. I wouldn't even put it in any particular bucket, but I would say probably gravitating more towards the complex than the simple, because of the need to pack more tech in a space where weight comes at a premium. You're going to have more and more complex boards for national security reasons. And no joke, we saw what happened with Huawei, with Nokia and Ericsson. Same's going to happen with EVs. It's already discussed, and it doesn't matter who's in the White House. that's one area of agreement, that whether it just be purely protectionist or legit, we don't want vehicles on the highways that are controlled remotely by what you could call a foreign adversary. It's just for simple reason. It could be hacked, and so forth. So what that means for our industry is more and more localization of manufacturing. So the boards are going to be made here in North America for North Americans, in China for Chinese, for Europe and Europe. And that trend was already happening after the tsunami we had in Japan, and followed by the whole semiconductor shortage. Boardrooms talk about, we got to do this local. So I think there's tremendous opportunity. I was at a Flex Supplier Summit a couple months past, and they threw some numbers up for the group. And this industry, it's just like getting started. It's going into explosive mode. And I would just say, lastly, I don't know if you ever saw my infographic I put together some couple of years ago, looking at the cost of an EV.
Yes.
And it looked at the battery and electronics and all the different parts. And it was roughly, electronics was just starting to cost the battery as the largest contributor. Oh man, that has massively increased. Partly due to the fact that batteries are going down, but electronics and the amount of and the sophistication is continuing to go up. So it's a great time to be in this industry.
And for my listeners and viewers who just heard and saw Brian talk about his infographic, it was a fascinating infographic. I'll get a copy of that and we'll put it in our show notes. So if you're watching this on YouTube, click the Show More button right down below, and you'll see that graphic on there. And if you're listening to this on your favorite podcast app, look at the show notes on the podcast app, and there'll be a link to that graphic. It does put things into perspective. Brian O'Leary, head of e-mobility at Indium, thank you so much for all your insight. I really enjoy our conversations. I enjoy them a little bit more when we're sitting in a bar talking about EVs.
Yeah. And
but that's all right.
Friends, we totally didn't script this. We just go with it.
Exactly. Well, we scripted it. I just threw the script away. That's exactly what I did. But I like where the conversation took us, and I do believe that there are a lot of opportunities within the electronics manufacturing world to serve this emerging market. Emerging implies that it's coming up out of the, like a submarine, slowly out of the depths, but it's more like a rocket going straight up. It's I don't know if it's technically exponential growth, but it does seem like it. And the technology seems to be expanding exponentially. So, which is, to me, super exciting, because you and I have said this before. I've said this to you before. When I was a kid, I used to read Popular Science, and we were promised flying cars by the year 2000. Everything was by the year 2000. This was in the 60s, so that was forever ahead of us. And I was promised flying cars and robots in the house. Well, we kind of have robots in the house. It doesn't look like the Jetsons robot, but they're little round discs that vacuum the floor and do things like that. But we never got our flying cars, and it's probably just as well. But I do think that the EV and the tech that we see that's frequently associated with EV, but also available on traditional cars, is as amazing as flying cars, maybe even more in many cases. So I'm excited to live in the times we're living in.
You need to come to CES this January, because I'm sure Xpeng and a few other will have flying cars there.
Yeah, well, that's scary. That is a whole uncharted level of reliability.
Well, they had one last year, so,
Yeah, well, there's hope. All right, well, Brian, thank you so much for the work you do. Thanks for sharing it with me and my audience, and all you do for our industry. I appreciate it. And to my audience, if you'd like to get more information on Indium and what they contribute to our industry, their information will be on our website as well. So again, thanks, Brian. I look forward to seeing you probably in March at the APEC show.
All right. We'll see you, Mike. Thank you.
Take care, Brian. Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on your favorite podcast app. If you're watching this podcast on the Reliability Matters YouTube channel, be sure to like and subscribe to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. And of course, a very special thanks to the Printed Circuit Engineering Association's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. And thanks as usual for your questions and episode suggestions. Please keep them coming. I love to hear from you. Send comments or episode suggestions to Mike at mikekonrad.com. Just remember, that's Konrad spelled with a K. To learn more about the Reliability Matters podcast, please visit our website at reliabilitymatterspodcast.com. Once again, thanks for listening or watching. Until next time, keep learning, keep doing it right, and remember, reliability matters. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.